we're going to continue on today. This will be objective 20. We're going to talk about triangles. We're going to find area of triangles using Heron's formula. Okay, I'm actually going to show you two formulas to find areas, and it's all going to depend on what you're given. Okay, so let me introduce to you Heron's formula first. Heron's formula says this. Like normally, let me ask you this. What if I have a right triangle? How do you find the area of a triangle? You do 1/2 base times height. So you use the old school formula. Like if you know the height of a triangle, so if I give you a right triangle, my question is, how do you know a true height? A true height means it makes a right angle with the base, right? A true height of anything. You know, I don't know if you're talking parallelograms, or if you're talking trapezoids, or if you're talking whatever you're finding an area of. A true height, remember, I don't know if from geometry, if y'all remember talking a slant height. If it's slanted, that's not a true height. A true height is perpendicular to the base, okay? So if you have a right triangle, is your height and your base perpendicular to each other? Yes, they are. So you could use A equals 1/2 BH, okay? The question we're going to talk about, though, today is what do you do when we have those obtuse triangles, okay? Something that looks like this, okay? And let's just say, like, normally, maybe like either in geometry or in math 8, or depending on in elementary school, you know, they would give you and say, here's the height. But we're not going to have that. How can you find the height? Just using your sides, okay? And so that's where Heron's formula comes into play. It says this. Area is going to be the square root of S times the quantity of S minus A times quantity of S minus B times quantity of S minus C, okay? And we know S is the semi-perimeter of the triangle. How do you find perimeter, by the way? So we're going to add them all up and basically take half of them. That's why it's semi, okay? Because you're going to take half of the perimeter, basically, okay? And that's going to give you your S, okay? Any questions so far? Okay, so let me go backwards, because this one I'm going to show you an easier formula to do. Let me do example 2 first. Is that okay? We can make this example 1 if that would be better. Let's just make this example 1. We'll just renumber them, okay? So my question is, what do you need to know to find the area? Like, do you need to know the angles? No, just the sides. So in this case, we have side, 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 so we're good to go. So we know area is going to be the square root of S times S minus A times S minus B times S minus C, okay? But the issue, do we know what A, B, and C are? Yeah, what are A, B, and C? Yeah, and in this case, like they named it P, H, and K, no big deal. A, B, and C just means those are your 3 sides, okay? And so it doesn't matter which one's A, which one's B, which one's C. I'm just going to, so you know it's easier, I'm going to go ahead and say here's A, here's B, here's C. Is that good? It doesn't matter, though. It's just your 3 sides. It doesn't matter what order you do them in, okay? So before we plug into our area formula, what else do we need to know? We need to know S. So how do you get S? You're going to add up all the sides and then divide it by 2, or times it by half, okay? So I'm going to do 1/2 times 7 plus 15 plus 12, okay? What is 7 plus 15 plus 12? What's the perimeter? Everybody agree with 34? I think I do agree. So S is going to equal what? 17. Okay. So now, let's just plug in. Can't write that very well. let's just plug into our area formula. So this is going to be the square root of 17 times 17 minus what? 7 times 17 minus, does it matter? Doesn't really matter. Whoops, let me go back. Minus 15. Really? Come on. Give me a pen. Minus 12 times 17 minus 15. Okay? And then we're just going to work that out. Okay? And you can probably stick this all in your calculator all at once. Okay? So you take a minute to do it. I'll take a minute to do it, and then we will compare. If you wanted to, you could work this all out first. Like work everything out underneath first. Some people, how many like to work it like in sections? Anybody like to work it in sections? Okay, so I'm going to do 17 times parentheses 17 minus 7 times 17 minus 12 times 17 minus 15. So what's that underneath the radical? What if I just did everything under the radical? What would that be equal to? I got 1700. And then if I actually want to find the area, let's just take the square root of that. Square root of 1700. So what's our area equal to? If we round it to the nearest tenth. 41.2, and we're going to say kilometers squared, because area is always squared. Squared kilometers. Okay? Pretty easy? Yeah? Okay. All right. So I want to show you, that's if you have side, side, side. Okay? So I want to go back to example 1, and I want to show you a second formula. Okay? An easier one. So my question to you, we'll make this example 2. If I can get my board to cooperate. Blue. Yeah, likes blue. Okay, we'll make that example 2. So my question is, why can't we go directly into Heron's formula? We don't have side, side, side. Okay, so my question is, what could you do? This is the discussion Mr. Gammons and I were having this morning. So how could I find the other side? How do you know to use law of cosines versus law of sines? You don't have a corresponding angle with a corresponding side. If you had a corresponding angle with a corresponding side, then you could use law of sines to find the other side. Do you understand that? But we don't. So you could use law of cosines, and that would be fine. That's, to be honest with you, that's how I normally do it. But Mr. Gammons was nice enough to come over this morning and show me a quicker way to do it. So y'all want to know the quicker way? He said when you have side angle side, when you have two sides, so here's what I'm going to say. If you can't remember this second formula, and you may want to put this like into your colored sheet so you do remember it, because I doubt it's in there. You know, if you don't remember this, then you can use law of cosines. Find that other side, then you can go to Heron's formula and find your area. Everybody with me on that? Okay. But he said this. If you have two sides with an included angle, you can find the area by multiplying 1/2 times the two sides. So I'm going to make this side sub 1 and side, not a 5, side sub 2. What does that mean? Side sub 1 and side sub 2. Yeah, side 1 and side 2. Just making sure y'all good with that. Side 2 times the sine of the angle, okay, the included angle, not just any angle. Maybe I should say the sine of the included angle. What does an included angle mean? The one that's in between the two sides. Does that make sense? Because if we named this, this would be side angle side. Does that make sense? The included angle is the one that's in between the two sides. Okay, so it's got to be that angle. Okay, so if we plug this in, this would be 1/2 times what? What's our first side? Does it matter? No. Okay, so 1/2 times 5 times 11 times the sine of what? 46 degrees. That's a lot shorter, right, than doing the whole line of law of cosines and then Heron's formula. So when I plug in 1/2 times 5 times 11 times the sine of 46 degrees, what do you get for the area? 19.8. And that's going to be yards squared. Well, basically, it's if I give you side, 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 you follow me? You're going to use Heron's formula. Okay, side, side, side. Use Heron's formula. Now, my question is could you use your law of sines or law of cosines to find the included angle and then go back to this formula? Yeah, it's not going to matter. Does that make sense? So I'm just telling you, though, this formula only works when you have what, though? Side, angle, side. Okay? So you got to make sure, you might even want to put like a little note on your colored sheet. This formula only works when you have side, angle, side. Okay? Heron's formula to find the area is when you have side, side, side. Okay? But so you can kind of toy between the two, but I guess you could use either one. Like if you had side, 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 and you found the included angle using your law of cosines, you follow me? Then you could go back to this formula. But it may be just as easy to go to Heron's formula with that instead of using law of cosines first. Okay? So let's look at this example. Now, my question is, do you have side, angle, side? So you cannot go to the formula I just showed you because you're missing what? You're missing this side right here. Like you could use side, angle, side if you found that formula. So I'm telling you right now, I'm just going to give you a second to think about it in your groups. You need to use law of sines or law of cosines. Does that make sense? And either find, you need to decide, do you want to use the second formula I gave you and do the side, angle, side? But you gotta have to use law of sines or law of cosines and find that side first. Or even when you do find that side, you could then use Heron's formula and do side, side, side. So does that make sense? You need to make a decision which way you're going to go with it. And either way, it's fine. So my question is, can we try splitting the room in half? And half of us do it one way and half of us do another way and see if we get the same answer? Okay, so let me go to this side first. Which way do y'all want to do it? Say that again. Using the sine formula? Okay, so they're going to find the side using, are y'all going to use law of sines or law of cosines? Law of sines, and then you're going to use the second formula, right? This side, do y'all mind being my guinea pigs? I want you guys to use law of sines, find the missing side, and then I want you to use Heron's formula. Okay? Let's see what we get. Okay, so we have right now we split everybody down the middle. Half of us are using side, angle, side, but we've got to find this missing side first. The other half of us are going to use Heron's formula using side, 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 but everybody had to find this first side first, and we found it to be, what y'all say, 6.2? 6.2 miles. Okay, so everybody used the law of sines and found that missing side first and got 6.2. So the question is going to be, what is it using side, angle, side, and what is it using Heron's formula? So I'm going to go ahead. I'm going to use the shorter one first. So area equals 1/2 one side times the other side times the sine of the included angle. So again, we're going to have to use this side, and here's our included angle, side angle side. So this would be 1/2 times 5.4 times 6.2 times the sine of 143. What'd you get when y'all did that? Did y'all use those numbers? No. Which way did y'all do it? Huh? $11 and 5.4? Oh, okay. So, okay. So it hopefully should work. I'm gonna plug this in first. Okay. Come on in. It's 10.2. Ooh! I'm so excited. Okay. So let me explain really quickly what we're doing. All right. So option 1, we used these two sides and this included angle, and we came out with 10.1. Okay. Option 2, we used the same formula, but now I'm going to do it in a different color. Let me do it in purple. They found this angle. How'd y'all find that angle, by the way? Did you use your law of sines? Okay, so they continued on with law of sines, and they found this angle, and then they used these two sides with this included angle. And so they plugged in 1/2 times 5.4 times 11 times 19.8. Oops, what did I forget? The sine of 19.8. So sine of 19.8. And then we came out with 10.1. Okay, and this is going to be miles squared, by the way. Let me add this, miles squared. And then I had one group that graciously did Heron's formula for us. So let me go back and do one more of these. So Heron's formula says this: A equals the square root of S times S minus A times S minus B times S minus C. How do you find S? S is your semi-perimeter, so you're going to add up all the sides and divide it by 2. So what do you get when you do that? This is the group that did it. 11.3. So we know S is 11.3. So then they just plugged in and did 11.3 times 11.3 minus 11. Then 11.3 minus 5.4, then 11.3 minus 6.2, and when you work that all out, they came up with 10.1 as well. So we had 3 different methods going on the floor, and everybody came up with the same answer. So do you understand what I'm saying is, the more we get into this, you got to use what you know. We know law of cosines. We know law of sines. We know area using Heron's formula. Then I gave you the sine formula for area too. But that only works with angle side or side angle side. Okay? Any questions on that? All right, so let me just give you a couple to try. So I want you to try this one. You choose how you want to solve it. Okay? You choose how you want to solve it this time. Okay? I want to know the area. All right, so if you're tuning into me, everybody in the classroom, I let them choose how they wanted to solve, and they all chose side angle side. Okay, now my question is can you use it as is right now? No. Okay, so first things first is you've got to find some missing sides in order to do. Okay, so I'm not going to do this part because this is law of sines, law of cosines. Actually, in this case, what will it be? Do we have, oh, we can find a corresponding angle. So they went ahead and they found this way first. And so what's this angle? 48. And so then they set up law of sines. What's this side? Because I'm sure some people use this bottom side. What did you get? 5.3. So if you were going to set up your area based on this, you could use this side, you could use this side, and which angle? The 50. You'd have to use the included angle, okay? And that would work. Anybody find the other side? Okay, so good. We did it different ways still. Okay, what's the other side using law of sines? 4.1. And not 7, 4.1. I would say it's a Monday, but it's not a Monday. It's a Wednesday. And if you're going to use the shortcut, you could use this side with this side. What angle would you have to use? You'd have to use the sine of 48. Or you could use this side and this side with the 82. You understand? It doesn't matter just as long as you get the included angle. Okay? I'm going to do it by Heron's formula. Just to prove that we should get the same answer, and we're all working. Everybody in the classroom got 8.1. All right, let's see what we get. So, area equals the square root of s times s minus a times s minus b times s minus c. And we know s, I'm going to add up all the sides and divide by 2. So help me out with that real quick because y'all got calculators. 4.1 plus 4 plus 5.3, hit enter, and then divide it by 2. Oh, did you do it by, did you get 8.1? Yeah, okay. All right. 6.7. Okay, so that's our S. So we're going to do area equals 6.7 times 6.7 minus 4. 6.7 minus, and you guys help me out with this since y'all got calculators, minus 4.1 times 6.7 minus 5.3. Okay? So when we take the square root of that, what does that give us? Are you just saying 8.1? Somebody punch it in their calculator and tell me, does it give you 8.1? All right, so we did get 8.1. And in this case, we'll say feet squared. Huh? Say it again. You got to take the square root of it. Does that make sense? You do all this, and then you got to take the square root of it. And it should give you 8.1. All right. So I think we're about finished. I'm going to give you one last one. You do it how you want to do it. Just check to make sure we got it. I actually feel like you'll be fine with it. Like knowing what we know, knowing that there's 2 possibilities, knowing that you only take the one that makes sense, then you use that to find the area. Does that make sense? So my question is, depending on whichever way you did, what did you come out with the area? 1.7? Everybody got 1.7. So I'm not going to do this one for you because I feel like y'all got it. Okay, area equals 1.7. And that's going to be inches squared. Okay, any questions on that? All right, last triangle that I'm going to give you looks like this. (26°, 6 and 8). That's fine. Go get your stuff. Okay, 26°, 6 and 8. Find the area. Okay, and what I'll do is while you're working on it, I'll pop up my notebook so you can see it a little bit better. Okay, 26°, 6 and 8. Do not forget, anytime you use the law of sines to solve, there's going to be what? 2 possibilities. Sometimes both work, sometimes one works, sometimes none of them work. And can I ask you a question really quickly here? You used law of sines here, didn't you? But my question is, like, you already had two angles. Does that make sense? And if you took and subtracted whatever, it doesn't matter if it's this one or this one, and subtracted it from 180, it wouldn't have made sense. So you had to just take those answers. This one, because I'm giving, you know what it all has to do with? It has to do with if I give you what? What kind of angle? A very, very small angle, right? To see if the second one works. So try that one and see what you can get. Okay, just use your normal ambiguous case and pick the triangle that makes sense to use your area. All right, I'm going to go ahead and start recording and start talking about this one. So this is the last one. I'm first going to solve this triangle, okay? We know, I'm going to label this the sine of A over 6. So far, so good. We know that when we use law of sines, what do we always have to do? When we're given one angle, one corresponding side, and another side, we know on that second angle, what do you have to do? You have to check to see if there's an ambiguous case, okay? So I'm first going to do the sine of 26 times 6, and I'm going to divide that by 8. And then I'm going to take the inverse sine of 0.3287783,601. And I'm telling you that angle A is equal to 19 degrees. Okay, I'm just going to round it. You could say 19.2. That would be fine. Okay, 19.2 degrees. Okay, I'm going to go ahead and draw my second triangle. I'm going to have to come back to the first one, but just so I know a lot of us get lost in, like, when we go to that second triangle, what information do we carry from the first? So we talked about it yesterday. Here's my second triangle. I know this is 26. You got to keep your given. And then what am I going to do to get that second option of that angle? I'm going to take 180 minus 19.2. And that's going to be 160.8. Okay, so let me ask you this. Let's find this third side right here. Let me go back to the original triangle. What's the missing third side? Help me out. 134.8. Okay, and so using the law of sines, what would this missing side be? 12.9. Okay, let's go to the red triangle. Y'all help me out. Grab your calculators. 180 minus 160.8 minus 26. Does that work? So in this case, what do we know about the second triangle? It's not going to work. Okay, so then, like, I don't think this is a big deal. Does that make sense? Then we're going to go back to the first triangle and use our area formula. Okay, what if the first triangle, what if they both worked? What would you have? Like, we talked about this yesterday. You got to make sure, not necessarily. Well, I guess you could. I don't know. I'd have to look to see if there would ever be a possibility of the two answers. But generally, one of the triangles probably wouldn't make sense. It would not equal the larger side. Does that make sense? Like, opposite angle, smallest angle, opposite side, largest angle. You just got to make sure it makes sense. Okay? I guess if they both made sense, then you could find areas of both the triangles, but I would think the areas should come out to be the same. Does that make sense? If both triangles worked, just in my mathematical mind. All right, so regardless of whether you want to use the short formula or Heron's? Short, okay. So pick a short formula. Area equals 1/2. Pick a side, any side. 6. So we're going to use this one. What else are we going to use? 8, meaning I have to use which angle? So I'm going to do the sine of 134.8. And so, what's our area come out to be? 17? 17.3? 17? Try again and make sure you get this. Did you use different sides? Did you use 6 and 8? So try one more time. 0.5 times 6 times 8 times the sine of 134.8. I got 17.029, which that'd be 17.0 or just 17. Okay, I'll come look at your calculator in a minute. Okay?